Binomial expansion. Learning intentions. Understand and use binomial theorem to expand x plus y to the power of n. Generate and use binomial coefficients with n choose or Pascal's triangle. Find a specific term, example the fourth term or the first few terms of an expansion. Handle constants and signs correctly in expansions like 2x minus 3y to the power of 4. This is the binomial theorem formula, and this is your success criteria. We expand a plus b squared as a squared plus 2ab plus b squared. Also, a plus b to be cubed is a plus b times a plus b squared, which is going to be a plus b times a squared plus 2ab plus b squared, which simplifies to a cubed plus 3a squared b plus 3ab squared plus b cubed. However, with higher powers, this method is too time consuming. Examining a number of expansions, the following patterns are noted. So we see here we have a plus b to be squared, cubed, to the power of 4 and to the power of 5. Notice that each expansion starts with 1a to the power of something and ends with 1b to the power of something. So to the power of 2, so a plus b to the power of 2, it started with 1a to the power of 2 and ended with 1b to the power of 2. For a plus b to the power of 3, it started with 1a to the power of 3 and ended with 1b to the power of 3. For a plus b to the power of 4, it started with 1a to the power of 4 and ended with 1b to the power of 4. And for a plus b to the power of 5, it started with 1a to the power of 5 and ended with 1b to the power of 5. Also notice that for a plus b to be squared, we have 2ab in the middle. For a plus b to be cubed, we have a 3 and another 3 in the middle. For a plus b to the power of 4, we have a 4, 6, and 4 in the middle. And for a plus b to the power of 5, we have 5, 10, 10, and 5 in the middle. The powers of a decrease by 1 from term to term. A to the power of 5, a to the power of 4, a to the power of 3, a to the power of 2, and a to the power of 1, which is just a. The powers of b increase by 1 from term to term. B squared, b cubed, b to the power of 4, b to the power of 5. The sum of the powers of a and b for each term is 5. So a to the power of 4 times b to the power of 1. So 4 plus 1 is 5. And then a cubed, b squared, 3 plus 2 is 5. And a squared, b cubed, 2 plus 3 is 5. And a to the power of 1, b to the power of 4, 1 plus 4 is 5. The number of terms in each expansion is 1 greater than the power, i.e. a plus b to the power of 3 has 4 terms, a plus b to the power of 4 has 5 terms, a plus b to the power of 5 has 6 terms, etc. The coefficients form Pascal's triangle. So we have 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. Over on the right here, we have 0, choose 0. So that gives us 1. And then we have 1, choose 0 and 1, choose 1. That gives us 1 and 1. We have 2, choose 0, 2, choose 1, and 2, choose 2, which gives us 1, 2, and 1. Then we have 3, choose 0, 3, choose 1, 3, choose 2, 3, choose 3, which gives us 1, 3, 3, and 1. Then we have 4, choose 0, 4, choose 1, 4, choose 2, 4, choose 3, 4, choose 4, which gives us 1, 4, 6, 4, 1. Then we have 5, choose 0, 5, choose 1, 5, choose 2, 5, choose 3, 5, choose 4, 5, choose 5, which gives us 1, 5, 10, 10, 5, and 1. The coefficients can be expressed in terms of combinations. So for combinations, in detail, see Chapter 5 Probability, where n choose or stands for the number of ways of choosing or objects from n different objects. So a plus b to the power of 5 is going to be 5 choose 0, a to the power of 5, plus 5 choose 1, a to the power of 4b, plus 5 choose 2, a cubed b squared plus 5, choose 3, a squared b cubed plus 5, choose 4, a b to the power of 4 plus 5, choose 5, b to the power of 5. So again, notice that all the powers add up to 5. So we have 5, and then 4 plus 1 is 5, 3 plus 2 is 5, 2 plus 3 is 5, 1 plus 4 is 5, and 5. All the coefficients can be quickly evaluated using the calculator with the n choose or function. For example, 5 choose 4, you press 5, then the NCR button, 4 equals and 5. For 9 choose 3, press 9, the NCR button, 3 equals, and you get 84. In general, we can write a plus b to the power of power of n is equal to n choose 0, a to the power of n, plus n choose 1, a to the power of n minus 1 times b, plus n choose 2, a to the power of n minus 2 times b squared, plus n choose 3, a to the power of n minus 3b cubed, plus dot dot dot, where the general term of this expansion is written as n choose or times a to the power of n minus or times b to the power of or. When calculating binomial coefficients, we note that n choose 0 or n choose n is equal to 1 for all values of n that are elements of the natural number set. So for example, if you have 6 choose 0, that would be equal to 1. If you had 7 choose 0, that would be equal to 1. If you had 20 choose 0, that would be equal to 1. Likewise, n choose n, so if you had 6 choose 6, or 5 choose 5, or 20 choose 20, it would all be equal to 1. N choose 1 is equal to n, so no matter what the n is, so it could be 7 choose 1, that will be equal to 7. It could be 8 choose 1, that will be equal to 8. It could be 20 choose 1, that will be equal to 20, etc. for all values of n that are elements of the natural number set. And then n choose or is equal to n choose n minus or for all values of n elements of the natural number set, i.e. 6 choose 4 is equal to 6 choose 2, because we are subtracting the or, which in this case is 4, from the n, which in this case is 6, and 6 take away 4 is 2, so that's where that 2 comes from. And likewise, 8 choose 7 is going to be equal to 8 choose 1, because 8 minus 7 is 1. Since the binomial coefficients start with n choose 0, the third coefficient is given by n choose 2. The binomial theorem gives a quick and efficient way to expand any binomial to a given power. The formula for the theorem is given on page 20 of the Formulae and Tables booklet. So binomial theorem is x plus y to the power of n is equal to n choose 0 times x to the power of n plus n choose 1 times x to the power of n minus 1 times y plus n choose 2 times x to the power of n minus 2 times y squared plus dot 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 n choose or times x to the power of n minus or times y to the power of or plus n choose n times y to the power of n. So this will always be the last term. Binomial coefficients, n choose or is equal to n choose or. So this is our formula book on page 20, and we can see that we have the formula there down the bottom. So this is known as binomial theorem. So you do not need to learn it off. It is quite a tricky formula. So just be very, very careful subbing into it. So example 1, expand fully p plus q to the power 6 and 2x minus 3y to the power 4. So I've just taken a screenshot from the formula book, and we're going to work out p plus q to the power 6. So the x is going to be equal to p. So the x in our formula is p. So that's just coming from there. The y is going to be equal to q. So the y in our formula is equal to q. And the n is equal to 6. So the n in our formula is equal to 6. So we have n choose 0 times x to the power of n. So the n is 6 and the 0 is just 0. So we have n choose 0. So we have 6 choose 0. And then the x is p and the n is 6. So we have 6 choose 0 times p to the power of 6. Then we have n choose 1 times x to the power of n minus 1 times y. So the n is 6 again. Then we have 1, so 6 choose 1. The x is p, so n minus 1 will be 6 minus 1, and y will be replaced with q. Then we have n choose 2 times x to the power of n minus 2 times y to the power 2. So n choose 2 becomes 6 choose 2. The x is p. Then we have n minus 2 as our power, so that's 6 minus 2. And then y squared is going to be q squared. And then we have n choose r. So we're just going to keep going. So notice on the bottom we had 0, 1, and 2. So now we have 3. So we have 6 choose 3. So then we have stuck onto that p to the power 6 minus 3, q to the power 3. So notice that the power of p was always the same. So it started with a 6, p to the power 6. Then it was p to the power 6 minus 1, p to the power 6 minus 2, and now p to the power 6 minus 3. So obviously the next one will be p to the power 6 minus 4. Then the q's, well, we had q to the power 1 in the second term, then q squared, then q cubed. So the next one will be q to the power 4. So we have 6 choose 4, p to the power 6 minus 4, q to the power 4. And then 6 choose 5, p to the power 6 minus 5, q to the power 5. And finally, 6 choose 6, p to the power 6 minus 6, q to the power 6. So we finish at when the n's match. So we have n choose n, so we're going to have 6 choose 6. So then putting 6 choose 0 into the calculator, 6 choose 0. So we're going to press 6. Then on this particular calculator, we're going to press shift and the division symbol, because you'll see above the division symbol in yellow, it has n choose or. Then you're going to press 0 and equals, and it will give you 1. So 6 choose 0 is 1, and then we're going to stick on p to the power 6. Next we have plus, and then 6 choose 1. So 6 choose 1 in our calculator is just 6. So 6 choose 1 is just 6. And then we're going to simplify the p and the q. So p to the power 6 minus 1 is going to be p to the power 5. And then we just stick on the q. Then we have plus 6 choose 2, which gives us 15. So you can check that in your calculator if you want. 6 choose 2 is 15. And then p to the power 6 minus 2 is going to be p to the power 4. And stick on the q squared. And then we have plus 6 choose 3. So you can put that into your calculator and you got 20. And then p to the power 6 minus 3 is going to be p to the power 3. And we stick on the q to the power 3. Plus 6 choose 4 is going to be 15. And then we're going to have p to the power 6 minus 4, which is p to the power 2. With q to the power 4 stuck on. And then 6 choose 5 into your calculator. You'll get 6. And then p to the power 6 minus 5. So that's p to the power 1. Or just p. And then we stick on the q to the power 5. And then 6 choose 6 is going to be 1. And p to the power 6 minus 6, well, that's going to be p to the power 0, which is just 1. So you'd have 1 multiplied by 1. So we don't need to bother writing that down. And then q to the power 6. So this is our answer. 1p to the power 6 plus 6p to the power 5q plus 15p to the power 4q squared plus 20p cubed q cubed plus 15p to the power 2q to the power 4 plus 6p q to the power 5 plus 1q to the power 6. So let's have a look at the pattern. So it starts with 1 and it ends with 1. So in terms of coefficients, we've got 1, 6, 15, 20, 15, 6, and 1. So you can see the pattern. Then in terms of the powers, they all add up to 6, and that's because we had a power 6 at the start. So you just have a 6 there. Then we have 5 and a 1, because q on its own is q to the power 1, and 5 plus 1 is 6. Then 4 plus 2 is 6, 3 plus 3 is 6, 2 plus 4 is 6. And p here is p to the power 1, so it's 1 plus 5 is 6, and then you have 6. And then notice the p's. So the p's are to the power 6, 5, 4, 3, 2, 1, and then technically 0 for the last term. And then in terms of the q's, in the second term, we just have q, and then squared, cubed, to the power 4, to the power 5, and to the power 6.